In today's video, just as I promised you last week, 40 Jamb questions on organic chemistry. Now, these questions are very likely questions, and I'm going to give exegetical and explicative solutions to these questions. I'm going to elaborate on each of the options. And so, therefore, I want you to listen very attentively. But if you have not subscribed to this channel, please, can you hit the subscription button now? God bless you. Thank you. Just as you are eating it, God bless you. I appreciate that. Hit the subscription button. Okay. Now, let's solve these questions exegetically. Question number 1. The functional group represented in the compound below is what? Now, this is the compound. Can we see this compound? So, does it belong to an alkanol, an alkanal, an alkanone, or alkanoid? All right. Now, when you see a compound that is having a C double bond hole and then joined to hydrogen. Can you see it this way? You will know that compound must be an alkanal. This is the family of alkanal. So C double bond O joined to H. And also you can recognize alkanal by CHO. So that is an alkanal. Compound having these features are alkanal compounds. But if you see something like this, CH3, C double bond O, CH3, yeah, this is going to be a family of alkanone and alkanone. Okay, so this is alkanol, or you see it RCOR prime in the form of CH3, CO, CH3. When you say CO in between our key groups, then you know that that is an alkanone. But for our question, the correct option is going to be an alkanal. So that's why option B is the answer. All right. Now, the functional group represented in the structure below is alkanol, alkanal, alkanone, alkanoic acid. Now, when you see something like this, when you see C double bond O joined to OH, that is an alkanoic acid. You can write it this way. So that is an alkanoic acid. All right. So therefore, the correct answer to number 2 is alkanoic acid. Question number 3. A primary amide is generally represented by what? Okay, so when you see an amide, it can either be primary, secondary, or tertiary. All right. Now, for our question, the correct answer is option B. So this is primary amide. Can you see? You're having 2 hydrogen. Secondary is when one of the hydrogen has been replaced by an alkyl group, so that you have it this way. C double bond O N H, one of the then RAS prime. Okay, so just like this. This is primary, this is secondary, this is tertiary, no hydrogen any longer. So that is tertiary amide. But for the sake of our answer, of our question, option B is going to be the correct answer. That is primary amide. All right. Now let's look at number 4. The functional group present in amino acid. Now, when you see the general structure of amino acid is given by this structure. You see NH2 and COOH. So here is an alkyl group, here is hydrogen. That's general formula of amino acid, okay? Now, an amino acid has 2 functional groups, which is the amino and the carboxylic group. So that's why we say amino acid is bifunctional. And in aqueous solution, it's going to be bipolar. Okay, so when you see the compound that is bipolar or bifunctional is amino acid. So that's why option A will be the correct answer. Okay, so I will go to number 5 now. Question number 5. The question says that The compound that will react with sodium hydroxide to form salt and water only is what? Now, of course, acid generally form salt and water when they react with a base, sodium hydroxide. So the correct answer is going to be option D, a carboxylic acid. I told you earlier that carboxylic acid has this group, or RCOOH. So can you see that this one is a carboxylic acid? That's the one that will react with water and with a base to form salt and water. Okay, so that's option D will be the correct answer. Now, question number 6 says that an organic compound with a pleasant sweet smell is likely to have a general formula of what? Now, which organic compound has a sweet smell? Which organic compound has a sweet smell? Okay, that is ester. Ester or alkanoids. Alkanoids are compounds that have the pleasant sweet smell. They smell like fruits, and that's why they are used in making perfumes. Esters are used in making perfumes, and that is going to be having the general formula of RCOR prime. Okay, so that is that. And so this R is CN H2N plus 1. And so that's why option C will be the correct answer. All right. The organic compound that has the fishy odor is what? Now, amine, which is RNH2. Mind you, amine is different from amide. I told you earlier, this is the one for primary amide. So this is amine. Amine does not have C double bond O. They don't have this. They don't have this carbon. All right. So therefore, amine, which is something like this, are the organic compound that has fishy odor. They smell like fish. So that's why option C will be the correct answer for number 7. Question number 8 says that which of the following compounds will give a precipitate with aqueous ammoniacal copper 1 chloride? Now, when you're talking about compounds that will give precipitate with aqueous ammoniacal chloride solution, with aqueous ammoniacal copper 1 chloride solution, that is going to be a terminal alkynes. Terminal alkynes. Terminal alkynes represented by this general formula will form precipitates with ammoniacal copper 1 chloride, ammoniacal silver nitrate, that's ammoniacal silver triazonitrate 5. So these two reagents are the reagent that is used to distinguish terminal alkynes from non-terminal alkynes. To distinguish terminal alkynes from alkene, because alkynes, they will respond to test of unsaturation, just like alkene. Alkene and alkyne will turn bromine water colorless, and bromine water is used for test for unsaturation. So, but these two reagents, ammoniacal copper 1 chloride, ammoniacal silver triazonitrate 5, will be used to distinguish alkene from alkynes, to distinguish terminal alkynes from non-terminal alkynes, to distinguish terminal alkynes from alkene. All right. So this compound is terminal alkynes. Which of the options relate to this? That would be option B. Option B is a terminal alkyne. You can see triple bond CH. That's how you know a terminal alkyne. All right. Question number 9. Which of the following reagents will be used will confirm the presence of unsaturation in compounds? That is bromine water. And just as I said earlier, these two compounds are the compounds that will decolorize bromine water. Okay, so how do you test for alkanol? Alkanol will be tested by what we call Lucas reagent. Lucas reagent is used to test for alkanol. All right, so that's just about that. Question number 10. The functional group present in an organic compound which upon treatment with saturated solution of sodium hydrogen carbonate gives effervescence. Now, this is a very common question in Jamb, please. So the organic compound that will give effervescence. Now you can remember the properties of acid. Acid will liberate CO2 from sodium hydrogen carbonate or sodium carbonate. So either of these two reagents can be used. So, and that compound must be a carboxylic acid. It is carboxylic acid that will liberate CO2, which is the effervescence. Effervescence means liberation of gas. So the functional group that is going to liberate gas from these two compounds must be a carboxylic acid. So RCOOH. Some questions, some years, they may give you an example of carboxylic acid. They may give option A, this one, option B, this one, option C, CH3CH2OH. You know, this is an alkanol. Of course, you will know that the correct answer is going to be a carboxylic acid. Carboxylic acid will give effervescence with these two carbonates. That's liberation of gas. I believe that's very simple. Question number 11 says that the carbon atom in ethanes are sp2 hybridized, sp3 hybridized, sp hybridized, sp2 hybridized, not hybridized. Now, when you hear alkanes generally are sp3 hybridized. Alkene carbons are sp2, that is alkene. Alkene, so ethene will be sp2 hybridized. So that is alkene is sp2 hybridized, and alkynes such as ethynes will be sp hybridized. So for alkanes, sp3. So therefore, option A going to be the correct answer. All right. Now, alkanals can be differentiated from alkanols by reaction with A2 2,4-dinitrophenhydrazine, B hydrogen cyanide, C sodium hydrogen sulfite, D Tollens reagent. Tollens reagent and Ferlin solutions are the two reagents that can be used to differentiate alkanal from alkanone. So that is Tollens reagent or Ferlin solution. So Tollens reagent will give positive tests with alkanal. Okay, so alkanals will react with Tollens reagent or Ferlin solution. So Ferlin solution will be used to differentiate something like ethanol from propanone. This is an alkanone. This is an alkanal. I told you earlier that when you see CHO, you know that's an alkanal. And when you see CO in between and a key group, you know that is alkanone. All right. So Tollens reagent or Ferlin solution can be used to differentiate these two. Okay, let's say this one is propanol. So propanol can be differentiated from propanone using Ferlin solution or Tollens reagent. So that's option D. All right. Question number 13, an example of secondary amine. Amine, this is primary amine. This is secondary amine. Or you can write it like this. R2H. This is secondary amine. All right. So an example of secondary amine is going to be a dibutylamine. Methylamine is primary, trimethylamine is tertiary. All right. So option B is the correct answer. The relative high boiling points of alkanol are due to what? Now that is hydrogen bonding. Okay. So alkanols can form hydrogen bonding, and because of that, every alkanol will always have a higher boiling point than its corresponding alkanes. So for instance, if we are talking about pentane and pentanol, you will know that pentanol will have a far higher boiling point than pentane because pentanol, an alkanol compound, can form hydrogen bonding. And so that's their property, okay, due to the presence of the OH. All right. So that's option D is the correct answer, okay? Question number 15. Which of the following will give an alkanol upon oxidation? Now, you need to understand that primary alkanol will give alkanol or alkanoic acid, depending on the type of reagent used. Okay, primary alkanol will react with oxidizing agent, strong oxidizing agent to give alkanoic acid, but it will react with mild oxidizing agent to give alkanol. Now, but secondary alkanol will give an alkanol. So therefore, the alkanol compound you are going to choose must be a secondary alkanol. Now, let's look at option A, proper 1-or. Now, when you hear 1-or, that alkanol is a primary alkanol. That alkanol is a primary alkanol. So, proper 1-or is a primary alkanol. So, it will not give alkanol. 2-methyl propan 1-or. So, this is still 1-or. That means the OH is on the first carbon. Okay, so primary alkanols are represented with alkan 1-or. Okay, so when you see an alkan 1-or, you will know that that's a primary alkanol. And when it is secondary alkanol, so, okay, sorry, this one you can also have alkyl alkan 1-or. So you can have alkyl at the back, okay? So that is primary alkanol. So that's why option A and B are primary alkanol. Now, option C, what type of alkanol is option C? 2-methyl butan 2-or. This one is going to be a tertiary alkanol because the position of the alkyl group and the position of the or is the same. 2-methyl. So when you see X alkyl, alkan XO. And you see that? The XO, X alkyl, the same thing. It means that that is going to be a what? A tertiary alkanol, like 3-methyl pentan 3-or, 4-ethyl octan 4-or. So 4-ethyl octan 4-or. You can see both of them are the same. So when you see that, you know that that is a tertiary alkanol. Okay? So you know that is a tertiary alkanol. Now, look at option D. This 2-methyl pentan 3-or, this one and this one are not the same. So, and this one is not 1. So it means if this one were 2-methyl pentan 1-or, you will have said that's primary. But because this is not 1, so therefore a tertiary secondary alkanol is known as alkan XO or Y alkyl, alkan XO. So this one and this one are not the same. And this X is greater than 1. It's greater than 1. Okay. So therefore, option D is going to be the correct answer because option D is a secondary alkanol. And when secondary alkanol are oxidized with strong or mild oxidizing agent, they will give alkanol. When secondary alkanol are oxidized with strong or mild oxidizing agent, they will give alkanol. So this one, which is a secondary alkanol, will be the correct answer. Okay, so tertiary alkanol, they don't undergo oxidation. They don't undergo oxidation. I believe you understand that. Question number 16 says that the type of alkanol represented by the structure below is what? Now look at this. Look at this. Now, how do you know the type of alkanol it is? You will look at the carbon bearing the alkanol, bearing the OH, bearing the alkanol functional group, OH. This is the carbon bearing the OH. This carbon bearing the OH is joined to how many carbon? Okay, this is directly bonded to this carbon, directly bonded to 2 carbons. So it's directly bonded to 2 carbons. Because of that, it will be a secondary alkanol. Now look at this. Now look at this. What type of alkanol it is? Is this, all right? Now this one is going to be a primary alkanol because this is the carbon bearing the OH functional group. This carbon bearing the OH functional group is directly bonded to one other carbon. So therefore, it is going to be a primary alkanol. But when you look at this is the carbon bearing the OH functional group. This is it. This carbon bearing the OH functional group is joined or is bonded to 1, 2, 3 carbon. So this is going to be a tertiary alkanol. It's going to be a tertiary alkanol. So therefore, for this one, which is directly bonded to 2 other carbon, is going to be a tertiary, it's going to be a secondary alkanol. So this one will be secondary alkanol. I believe that's very simple. So that's why option B will be the correct answer. Question number 17 said the IUPAC nomenclature of the compound below is what? Now, when you look at this compound, does it have functional group? Of course, it has a functional group, the chlorofunctional group. So therefore, your taking the longest carbon chain must involve this Cl, okay? So therefore, let's just take, since it's the first carbon, so let's just take it. So if you count it towards this side, 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4, 5. So counting it towards the right will give us the longest carbon chain. So on position 2, we have methyl, and we also have ethyl. So ethyl will come first, and we have chloro on position 1. So that's going to be 1 chloro, 2 ethyl. Ethyl will come before methyl. Pentane, that is an alloalkane. Okay, so 1 chloro, 2 ethyl, 2 methyl, pentane. So which is option D. I believe that is very simple. So when you're taking nomenclature, you just got to get it right. Okay. Yeah, before I continue solving this question, I would like to inform you that next week, by weekend, by Saturday, I'll be uploading 40 likely calculation questions in UTME 2024. And so please, if you have not subscribed to this channel, I want you to please hit the subscription button now. I have a lot for you in this channel. I upload videos for the undergraduates, videos on spectroscopy, videos on organic chemistry, videos on physical chemistry, videos on analytical chemistry, for pharmacy students, for medical students, for everybody. So if you have not subscribed to this channel, please hit the subscription button. Please support this channel by subscribing. God bless you. All right, let's continue to dasu rasu and rasu dasu. Okay, so that is, you can check that in your dictionary, dasu rasu or rasu dasu. So that is rasu dasu. That is to show brightness, excellence, brilliance. Okay, now question number 18, that's by the grace of God. Question number 18, the compound below is the oxidized product of what? Now, when you look at this compound, you will know that this compound is an alkanol because this compound is C double bond hole here in between carbon, in between this carbon. Maybe it is a methyl, this is an ethyl, okay? So this compound is an alkanol, okay? So how do you know? So this compound is from CH3, CH2, OH, H, CH3. This compound is formed from this. Okay, you know, oxidation. Oxidation is the removal of hydrogen. I remove this hydrogen, I will form this. That is if I'm using strong oxidizing agent or mild oxidizing agent. So this compound is formed from this. So if I reduce this copper, if I reduce this compound using this compound or using NaBH4, I'm going to get this. So this compound, this is butanone or butanone, is formed from butan2-ol. It's formed from butan2-ol. So therefore, this butan2-ol is formed from butan2-ol. Option C is going to be the correct answer. Question number 19 says that which of the following does not react with acidified K2Cr2O7? Now, the alkanol compound that does not react with oxidizing agent must be a tertiary alkanol. N-propanol. N means normal. So that is normal propanol. That means propan1-ol. Propan1-ol will be oxidized with K2Cr2O4 because the primary alkanol to give us propanoic acid because this is a strong oxidizing agent. B, this is butan2-ol. Butan2-ol will be oxidized to butan2-one because it's secondary alkanol. 2-methyl, can you see this one? And this one is the same. That is the only way, one of the vital way to identify a tertiary alkanol. So a tertiary alkanol does not react with oxidizing agent. So therefore, option C is going to be the correct answer. Question number 20. The product obtained when KMnO4 reacts with alkene is what? Alkene reacts with KMnO4 to give diol. And another name for diol is a glycol, diol. So if you have ethene will react with KMnO4 to give ethylene glycol, an antifreezing agent. Can you see? Or you can call it ethane-1,2-diol. Ethane-1,2-diol. That's an antifreezing agent. So this one, a diol, that means 2-ol, diol, is called a glycol. So that's our options. A will be the correct answer. Now, when you look at something like glycerol, glycerol is a byproduct from saponification process. That one is a propan-1,2,3-triol. That is called a glycerol. So that it's not the same thing as glycol. So option A is called diol. Ethanol reacts with excess acidified K2Cr2O7 to give what? Ethanol is a primary alkanol, and primary alkanol will react with strong oxidizing agent. This is a strong oxidizing agent to give alkanoic acid. So this ethanol, a primary alkanol, will react with strong oxidizing agent such as KMnO4 to give ethanoic acid. So that's why option D will be the correct answer. The incomplete oxidation of ethanol. So if you are using a mild oxidizing agent such as copper in the presence of heat, such as pyridinium chlorochromate, so those ones, we be mild oxidizing agent. And so the incomplete oxidation of ethanol will give ethanol. That is option B. Option B. So ethanol, the process of oxidizing primary alkanol will first be oxidized to alkanal before oxidizing to alkanoic acid. So this is the incomplete, this is the complete. Mild oxidizing agent, we take it to alkanal. Strong oxidizing agent, we take it from primary alkanol to alkanal, then to alkanoic acid. So, and the reaction is very fast at this point when it is a strong oxidizing agent. But for weak oxidizing agent, ethanol, which is something like this, ethanol will be oxidized to ethanol. That is incomplete oxidation. And from ethanol, incomplete oxidation, it will be oxidized to alkanoic acid. Okay, so that's what happens. I believe we are getting it right. I believe you are taking proper note. So you can still backward this video just to make sure you take the proper note. Yeah, so that's why option B is going to be the correct answer to that. Thank you. Now, yeah, before I solve the remaining questions, I would like to share this with you. That's from the Bible, Lamentations chapter 3, verse 27. It is good for a man that he bear the yoke in his youth. Now, what is the Bible saying here? It is good that as a young person, you give the best that you can give now. Give the best you can give now. It is at this youthful age that you can build for your tomorrow. You know, a lot of youth are wasting their lives on immoralities. They go with boyfriend, girlfriend, they're having sexual immoralities, and they are getting impregnated, and they are committing abortion. They are committing abortion. They are not focusing on their academics. They are not praying for tomorrow that God will bless them, that God will place them high in life. They are just wasting their life. They say they are enjoying, but they don't know that it is life that is destroying them. They are destroying their tomorrow. They are not building for tomorrow. They are not building for tomorrow. They are not giving their best, the rigorous academics to obtain good certificate. You know, many people, this you hear me now, they are going from one boyfriend to the other instead of sitting down properly and reading their book rigorously to achieve their desired goals. But they are wasting their life. They don't understand that the best favor you can do for yourself, for your tomorrow, for your unborn children is to give your best to your academics now, to give your best to prayer, to give your best to the service of God. My dear listener, have you accepted Jesus Christ as your Lord and Savior? Time is running out of you and you are missing a lot. The grace of God is available for you today. So that because without Jesus, without the help of Jesus, you may not have that focus that you are supposed to have. So, but when you make Jesus your friend, he will help you as he helped me. He will give you grace to overcome temptation. He will give you grace to stay focused. And he will give you success in life. Life will fall for you in pleasant places because you will be a friend of Jesus. He will answer your prayer. He will lead you in the path of greatness. I pray that you'll be serious today in Jesus' name for you to bear the yoke at this youthful age where you have all the energy. You must, number one, give your life to Jesus. Give your best to the service of God. Give your best to prayer, to praying for tomorrow. When I was growing up, what I prayed for, God answered them. God answered me. I had success academically. I succeeded, was lecturing. I married the kind of wife I prayed for. Everything, God did it for me. God can also do it for you. And he still have a lot of things for me because I belong to him. And he has sent me to you that he has a plan for your life. Be ready for number one, to accept Jesus. Number two, to pray for your tomorrow. Number three, to give your best to your academics and every other things that you can do to enhance your skills. I pray that God will help you in Jesus' name. It is now that you can do these three things, and it will not be too late for you in Jesus' name. Thank you, Jesus, for this person that has heard your word. I pray that you will save his soul. Pray that this word will make meaning to him and he will follow Jesus. In Jesus' name, I have prayed. Amen. All right, so I continue to solve the questions. Question number 23 says that the IUPAC nomenclature of the compound below is what? Now, when you look at this compound, you see this compound as a functional group, the double bond functional group. So therefore, your carbon counting must involve this one. Okay, so you are counting 1, 2, 3. 1, 2. Here we have 2 carbons. So 1, 2, 3, 4. So I take it this way. And so this one is going to be a substituent. And being a substituent, you start your numbering from the side closest to the functional group. And so this one is going to be a 2-methyl. So this compound is going to be a 2-methyl but1-ene. Okay, but1-ene, because it's 4 carbons. So that's going to be option B. That's option B. Question number 24 says that the IUPAC nomenclature of the compound below is what? Now, when you look at this compound, it has 2 functional groups, the bromo functional group and the alkene functional group. Okay, so therefore, you will start you must, in your carbon numbering, it must involve these 2 functional group. So therefore, I will number from the one. Now, the alkene is the functional group of higher priority. So therefore, I will number from here 1, 2, 3, 4, 5. So that's going to be that. So now the correct answer is going to be 5-bromo 3-ethyl pent 2-ene. So that's going to be option B. Option B. Okay. Now, question number 25. The reaction between ammonia and ethyl ethanoate will produce what? Now, this is ethyl ethanoate. This is an ester. So, when ethyl ethanoate reacts with ammonia, NH3, it is going to produce, when ester reacts with, so when ester reacts with ammonia, what is going to happen is that this one is going to turn to amide, and this one will turn to alkanol. So that one of the H comes here, we are going to have ROH, and then this one, RCNH2. So that is amide. So this one, so therefore this one will turn to CH3, CONH2 plus C3, CH2OH. So that's going to be the product, these 2. So that is ethanamide and ethanol. Ethanamide and ethanol. That is option C. The chemistry of ethyl ethanoate is actually very important for UTME. Now, you need to know that, so that is one of the important reactions of ethyl ethanoate. When ethyl ethanoate reacts with ammonia, it's going to form ethanol and ethanamide. Another important reaction that UTME normally asks is, if ethyl ethanoate react with lithium tetrahydroaluminate 3. If it reacts with this one, so this is going to produce 2 moles of ethanol. It's going to produce 2 moles of ethanol, because when ethyl ethanoate or when alkanoates react with this strong reducing agent, it's going to form alkanol only, primary alkanol. Okay, it's going to form primary alkanol. So if ethyl ethanoate react with this strong oxidizing agent, it is going to give us ethanol. It's going to give us ethanol. Okay, so I'm going to be uploading some chemistry of on all these functional group later on. Yeah, so please subscribe to this channel. So, but for the sake of UTME, please put these 2 questions at the back of your mind in case you meet it in your exam. Okay, question number 26 says that 2-methyl-butanol is an example of A, dihydric alkanol, B, primary alkanol, B, C, secondary alkanol, D, tertiary alkanol. Sorry, this one is meant to be option C. All right, so as I explained earlier, that when you see the position of the methyl and the ol, once it's the same, it's going to be a tertiary alkanol. So option D is going to be the correct answer. Okay, so now question number 27 says that the polymer used to replace steel parts of machine is what? Is nylon. That is option A. Option A is going to be the correct answer to that. So nylon is not just the nylon you used in wrapping sugar or other nylon. This nylon is actually polyamide, which is produced from the reaction between a dicarboxylic acid and diamine. So that is nylon. Okay. Perspex is used to, to make carrier lights. Okay, and bakelite is used to make plugs. So nylon is used to replace steel parts of machine. Perspex is used to make carrier lights. Bakelite, this bakelite is used to make plugs, the plug and the switches, all those things. That is bakelite. PVC is used to make pipe. That's PVC. So that's for that. So that's the answer. Option A is the answer to number 27. Number 28 says that the polymer used in making carrier line. So as I said earlier, that is perspex. Okay, so that's going to be perspex. And so this polystyrene is used. Light polystyrene is used to make ceilings and also used to making for making material that is used in packing fragile objects. So this polyacrylonitrile is used in making clothes. So it's like artificial wool, okay? So polyacrylonitrile is used in making wool clothing. So perspex is used for making carrier lights. PVC is used for making pipe, okay? So question number 29 says that polystyrene is widely used in packing materials because of its what? Because of its high compressibility. All right, so question number 30 says that the monomer of natural rubber is what? The monomer of natural rubber is what you call isoprene. And the IUPAC nomenclature of isoprene is 2-methyl, that's 2-methyl-butanol 3-diene, okay? So that is going to be option A. Option A is correct answer. So the monomer of natural rubber, the PT unit of natural rubber is what you call isoprene. And the IUPAC nomenclature of isoprene is 2-methyl-butanol 3-diene. Okay. Now, question number 31 says that vulcanization involves the removal of single bond, a double bond, a polymer, a monomer. Now, as I explained earlier, okay, I prepared a slide. Look at the next slide. Okay, so this is natural rubber. So this is natural rubber, and this is it. This is the this is isoprene. So this is the structure of isoprene. This isoprene combined together, the form natural rubber. This is natural rubber, and this is the mechanism of the formation, and this is natural rubber. Okay, so this is the polymer, the natural rubber is so long and so on like this. So this is how this one, as can you see, this is how it formed this one. Now, vulcanization of rubber is the hardening of rubber when heated with sulfur. When the latex, the rubber got it from the latex got it from rubber tree, which is this one. That latex gotten from the rubber tree is this one. Okay, so when treated with sulfur, each two strands, each two polymers, we combine together, and so what happens is that that double bond, this is how it happens. So you have two of it. You have two. So this is, this one, let me just draw one more here. So this one, this one comes here, this one comes here to form this one. So the sulfur is going to be binding them together like that. This one comes here, this one comes here. That's the sulfur. This one form bond with this sulfur. Okay, so to form this. So that is vulcanization of rubber. So that is the steps that is involved in vulcanization of rubber. And so what we are going to see is that the double bond will be removed at the end of the day. All right. So the double bond, the whole of the double bond will be removed at the end of the day. So that is how vulcanization of rubber occurs. That's how vulcanization of rubber occurs. So the vulcanization of rubber involves the removal of double bond. It involves the removal of double bond. All right, so the monomer of natural rubber, as I said earlier, is 2-methyl-butanone, butanone 3-diene. Number 31, vulcanization of rubber involves, the hardening of the rubber, and that involves the removal of double bonds. So it involves the removal of double bond. Now, the repeating unit of neoprene. Now, the neoprene is the first synthetic rubber. And the repeating unit of neoprene, the synthetic, the monomer or the repeating unit. When you hear repeating unit, it means monomer. So the monomer or the repeating unit of neoprene, which is what we call synthetic rubber, so is 2-chlorobutanone 3-diene. So that's option C, 2-chlorobutanone 3-diene. Now, can you tell me now the difference between isoprene and neoprene? So this one is a monomer. This isoprene is a monomer of natural rubber. While neoprene is a polymer. Yeah, it's a polymer, which is a synthetic rubber. Produced from 2-chlorobutanone 3-diene. All right. So that's how simple it is. So I believe you have gained something. So I'm going to be going to the question number 33 now. Question number 33 says that the production of soap from triglycerides in the presence of a base. Now, this triglyceride is fat and oil. So the production of soap from fat and oil in the presence of a base, which is sodium hydroxide most of the time, is what? So that's saponification process, right? The process for producing soap is saponification process. And this saponification process, it is hydrolysis of polyester. So a triglyceride is actually, consisting of 3 ester joined together, and is going to be what? Hydrolysis. So hydrolysis is also, if saponification is an hydrolysis, okay? Now, and of course, The base that we produced, the byproduct of saponification process is glycerol. That's propan 1, 2, 3 triol. Glycerol, glycerol, glycerol. Okay, that's propan 1, 2, 3 triol. The reaction of ethanol with H2SO4 at a temperature of 135 degree is what? Now, when ethanol, when it reacts with conc H2SO4, the dehydration of with conc H2SO4 at elevated temperature, okay, that is conc H2SO4 at a temperature of 175 to 185 degree, that is elevated temperature, is going to produce alkene, which is ethene. That's dehydration. The function of the H2SO4 is to dehydrate. But if it is reacting with conc H2SO4 at a lower temperature of 135 to 145, so that is going to be producing ethoxyethane. Ethoxyethane. So the dehydration of ethanol at a low temperature is going to produce ethoxyethane, but at elevated temperature is going to produce ethene. Okay. Now, the gas responsible for most fatal explosion in coal mine is called what? Methane. Methane is what is responsible for the, fatal explosion in coal mines. So that is methane. That is methane. So methane, the chemistry of methane too is also very important. You also read chemistry of methane, ethene, ethyl. So you have to know some things about them. Yeah. So for instance, okay, how do we produce ethane? Ethane can be produced from decarboxylation of ethanoic acid. That is when you eat, that's through eating. When you eat ethanoic acid, it's going to decarboxylate. So this COO will escape. And so that this H join with this one to become CH4, and that is decarboxylation of alkanoic acid. Okay, so that is for that. Or when you react ethanol, sodium ethanoate with sodium hydroxide, you're also going to be producing methane. You're going to be producing methane. So methane is actually the gas that causes explosion in coal mine. So it is, called a fire damp. Okay, so it is called a fire damp. All right, now another thing you have to know about the chlorination of methane. When methane reacts with chlorine, it's going to be producing, it's going to produce produce chloromethane, then to dichloromethane, then to trichloromethane, which is what you call chloroform, then to tetrachloromethane, The chlorination of methane, we produce those four compounds. So we produce monochloromethane, dichloromethane, trichloromethane, tetrachloromethane. This dichloromethane and tetrachloromethane are normally used in dry cleaning. They are normally used in dry cleaning. So now, when this chloroform trichloromethane, which is what you call chloroform, is used as anesthesia in minor surgery. So, and that is trichloromethane, option C. So that's something you should put at the back of your mind. Now let's talk about ethane. Ethane is dissolved in acetone because of what? Because it is unstable. So because ethane is unstable, it will be dissolved in acetone just to preserve it. All right. So please put that at the back of your mind. Now, look at this diagram. We're using this question, first diagram to solve question number 39 says that the function of copper 2, this is the setup for producing acetylene. Acetylene is what you call ethyl. Okay. Now, this is the setup for producing ethyl. Here, ethyl, is produced by the action of water on calcium carbide. When calcium carbide, reacts with water, that's going to produce calcium hydroxide. And, this is ethyl. So the action of water on ethyl will what? Will produce action of water on calcium carbide will produce ethyl. And that is what that's what hunters they used in making their headlamp. That's what they are using in making their headlamps. So it will cause brightness of headlamp to produce light for headlamp. So yeah, that is ethyl. That's one of the vital use of ethyl. Okay. So it is used for producing light in headlamp. And so the production of ethyl will involve the action of water on calcium carbide. Okay. And the ethyl that is produced will be passed through acidified copper sulfate solution before pass through water. All right. So the function of the copper 2 tetravalent in dilute H2SO4 is to what? To absorb phosphine impurity. Okay. Is to remove, to absorb the impurity. And the impurity is phosphine. That's pH3, to remove this impurity. Okay. Now, why is it that what's the function of this sand? Why do we have to put the calcium carbide on sand? That is another question that is very common in Jamb. And the reason is to avoid the breaking of this flask because the reaction is very exothermic. So if you just put the calcium carbide on the flask without putting sand first, you just see that this glass will break underneath. All right. And that's going to affect the reaction. So option B is the answer to this. So the calcium carbide is put on sand to prevent breaking of the glass. Okay, question number 40 here is how ethene or ethylene is produced by the reaction between conc H2SO4 and ethanol. So, and then you heat it at an elevated temperature. So, as I explained earlier. So, now you pass it through an empty flask, then you pass it through sodium hydroxide. Now, the question is saying, what is the function of the empty flask? Why do we have to put the empty flask there? So, the empty flask is actually to prevent this sodium hydroxide from sucking back into this reaction flask, into this reaction mixture, to prevent this H2SO, because if you pass this one directly into this sodium hydroxide, there is tendency that the sodium hydroxide will suck back into this reaction mixture. So the function of the empty flask is to prevent this sodium hydroxide from sucking back into the reaction mixture. Now, what is the function of sodium hydroxide? The function of the sodium hydroxide, that's another common question in Jamb. The function of the sodium hydroxide in the production of ethene is to remove SO2 and CO2 impurity. So that is that's the function of the NOH. But our question is asking for the function of the empty flask. So, and that is to prevent sodium hydroxide from sucking back into this reaction mixture. I believe you have gained a lot, from this video. Kindly share this video with your friends, share it with your roommates, your bucket mate, your slippers mate, or your mateable mate. Share it with your siblings, share with everybody, your students, your friends, and more is still coming. I want you to just please hit the subscription button. As I've said earlier, this Saturday, be expecting 40 calculation questions, likely questions in UTME 2024. Thank you very much for watching to the end. Subscribe, 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 subscribe. God bless you.